Let us understand how do we solve polynomial inequalities using three different methods, and here are six examples for you. Now let us see how do we find the intervals where the following inequality is true, which is x plus 1 times 2x minus 5 greater than equal to 0. First step will be to find the x-intercepts of the equation x plus 1 times 2x minus 5. It really means wherever the y value is 0, right? So if you equate to 0, it is going to be 0 only for x plus 1 equals to 0, which is at x equals to minus 1, or 2x minus 5 equal to 0, which is at x equals to 5 by 2. So we have two zeros. On a number line, let us take these two zeros. So one zero is at minus 1, the other one is at 5 by 2. Right. Now, between these two zeros, we are going to take test points. A test point on the left side of minus 1 could be minus 2. Something in between, 0 is a good number, and more than 2.5, we can take this as 3. So these are my three test points. Now, for minus 2, we'll analyze x plus 1 times 2x minus 5, whether it is positive or negative. We can make a table of values. So, interval table we can make. So, we have x plus 1 as one of our factors, the other one is 2x minus 5. If I substitute minus 1 in If I substitute minus 2 in x plus 1, what do I get? So let me just show you clearly. These are the intervals, right? So if I substitute minus 2, I get negative. For 0, I get positive. And here again, I get positive. For 2x minus 5, minus 2 will give me minus 4 minus 5, which is negative. 0 will again give me negative, and 3 will give me positive. When I multiply two negatives, what do I get? I get positive. A negative and positive will give me negative, and two positives will give me positive. So we can see that on this sign graph, we have positive at the two ends and negative in between these two zeros. So the inequality, which is x plus 1 times 2x minus 5 greater than equal to 0, will include the zeros and the two intervals on the sides. So our solution will be from minus infinity to minus 1, where minus 1 is included, and or union from 5 by 2 to infinity. Infinity is never included. Does make sense to you, right? So this is one strategy we can use for solving quadratic inequalities, right? So I hope this process is clear. Now, let us do question number 2. We need to show. I hope this process is clear. Now let us solve the inequality in question number 2, which is minus 5x times x plus 3 whole square is less than equal to 0. So zeros are part of solution, okay? Let's find the zeros first, which are the x-intercepts. X-intercepts, as you can see, are at x equals to 0 and at x equals to minus 3. So let's make our interval table. So on a number line, we can take the points, which are the zeros, which are at 0 and minus 3. So let's say this is minus 3 for us, and here we have 0. We'll begin by taking the test points in each interval. So the test point from minus infinity to minus 3 can be minus 4. Between minus 3 and 0, it can be minus 1, and after 0, we can take 1 as our test point. Now we'll examine the factors in each interval. We have two factors. One of them is minus 5x, and the other one is x plus 3 whole square. If I substitute minus 4, I get minus and minus, a positive number. Negative 1 times negative 5 is also positive, but 1 times this will give me negative number. As far as x plus 3 whole square is concerned, any number will be always positive. If you multiply, then the relation will be positive in the first interval, which is from minus infinity to minus 3. And in the middle also it is going to be positive and is going to be negative from 0 to infinity. Since we are looking for less than equal to 0, what should be our solution? Well, the solution should be right there from 0 to infinity. And therefore, we have our answer, which is from 0 to infinity. You get the idea. So that is how we can make use of interval table to solve the equation. Inequality. Here is question number 3. X square minus 1 greater than 0. You can pause the video, answer the question, and then look into my suggestions. Well, in case you want to learn directly from me, feel free to send an email to globalmathinstitute@gmail.com. Our students are right there on the top, getting scholarships and admissions to the best universities. Let us see how do we solve this problem, which is x square minus 1 is greater than 0. So zeros are not the part of solution. Factor the equation. Difference of squares, we can write this as x plus 1 times x minus 1 greater than 0. Once we have this equation, go with the x-intercepts. Now x-intercepts making these factors 0 are the values of x as minus 1 and plus 1, correct? So now, we'll again, on a number line, check the intervals. We have two zeros, one at minus 1, the other one as plus 1. We need to take test points. So from minus infinity to minus 1, minus 2 can be the test point, 0 in between, and 2 thereafter. The factors are x plus 1 and x minus 1. If I substitute minus 2, I get negative number, 0 will give me positive, 2 will give me positive. In x minus 1, I'm going to get negative, negative, and here I'm going to get positive. So when you multiply two negatives, you get a positive. This is going to be negative, and that is going to be positive. Since we are looking for greater than 0, right? We're looking for x square minus 1 greater than 0. Our solution will be these intervals. You understand? And we can write down our answer, which is from minus infinity to minus 1, or from 1 to infinity. Does it make sense to you? Right? As you can see, if you make a sign chart, this is going to be positive in this interval, negative in between, and positive. We're looking for greater than 0. So that is how you get it on the sign chart. So sign chart corresponds to our equation and its solution, inequality. Here is another question, which is minus x squared plus 6x minus 16 less than 0. Now, we need to factor it, correct? So we have minus x squared plus 6x plus 16 less than 0. We can multiply everything with negative. In that case, what happens? Well, inequality sign will change. we could rewrite this as x squared minus 6x minus 16 is greater than 0. Do you see that? So when you multiply by a negative number, this inequality sign also changes. 7 is greater than 5, but minus 7 is less than minus 5. Makes sense, right? Now, let us factor. We're looking for two numbers whose product is minus 16 and sum is minus 6. 8 times 2 can work for us. And so we get x, 8 should be negative, times x plus 2 greater than 0. So we have factored. Now, on a number line, you could also sketch this function. Or on a coordinate plane, you can sketch this function. We are looking at two zeros, one at minus 2, the other one is at 8, and the parabola opens upwards. So here is a new technique for you, which you should explore. So this parabola is going to be kind of like this. As you can see, the zeros are at minus 2 and 8. We want greater than 0, that means we are looking at these portions, right? So our solution is from minus infinity to minus 2, union from 8 to infinity. So that is a very good approach. So you can combine this with the approaches learned so far. Now we have two questions for you. I'd like you to use the three different approaches which we have. One is using the sign diagram. Second, we use interval table. And the third, using the graph. You can apply any of these to solve these inequalities. Two of them, they are like your test questions. Feel free to write a comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.